Chapter 11, Liquids and Solids. Exercise 11.75. Part A. How much heat is required to warm 15 grams of ice initially at negative 17 degrees Celsius to steam at 116 degrees Celsius? The heat capacities of ice, water, and steam are given. The enthalpy of fusion and the enthalpy of vaporization are also given. Now let's do the calculation. There are 5 steps. Number 1 step, we heat up ice right from negative 17 to 0 degrees Celsius. Step number 2, fusion. At 0 degrees Celsius, we melt the ice. After the ice is melted, we'll heat up the water liquid from 0 to 100 degrees Celsius, followed by vaporization. This vaporization needs a lot of heat. As you can see, we need 40.7 kilojoule of heat to vaporize only 1 mole of water. Alright, number 5. Step number 5. Step number 5 will heat up steam from 100 degrees Celsius to 116. So we'll do all this. Now let's look at the first step. Number 1, we'll heat up the ice from negative 17 to 0. We need the specific heat of ice, 2.09. We need the mass, we need the delta T. We have all the information, but because the answer is gonna be in kilojoules, I'm gonna do the conversion right here. It's gonna be 15 the mass times the specific heat capacity. So a word is missing here. The specific heat capacities of ice, water, and steam on this. Alright, and then times the temperature change. I'm gonna just have 17 here, because you can see the temperature change is from negative 17 to 0, final minus initial, it's this, and then divided by 1000, so that we'll have the value in kilojoule instead of joule. Now let's do fusion. To do fusion, we need the enthalpy of fusion, which is 6.02 kilojoule per mole, and we multiply this by the number of moles of ice over here. The molar mass of water is roughly 18.016. I'm gonna just use 18 here for convenience. Alright, I'm using kilojoule here, so this is in joule, I'm using kilojoule. Now we're gonna heat up liquid water from 0 to 100 degrees Celsius. So I'll just copy this part. We still have 15 grams of water, but now we're looking at liquid. Liquid has a different specific heat capacity, and the temperature change is different. It's from 0 to 100. Alright, so we have this term. Now we'll talk about vaporization. Step number 4, vaporization. It's similar to the calculation of fusion, but you can see the enthalpy of vaporization is 40.7 kilojoule per mole. So we need to change this to 40.7. It comes from this number. This is in joule. We need to convert it to kilojoule. Alright, and finally we'll heat up the steam. To heat up the steam, we use the specific heat of water steam. Alright, so the last part, 15 grams of water steam multiplied by the specific heat capacity of steam, which is 2.01, and the temperature change is from 100 to 116. So alright, now we have the final answer. It's going to be 46.2 kilojoule. As you can see, we have 5 terms. I'm summing up 5 terms because this process involves 5 steps. First step, we heat up ice from -17 to 0. We need the specific heat capacity of ice here times the grams of ice times the temperature change. Step number 2, fusion. We have the number of moles of ice and the heat of fusion. Step number 3, we heat up water liquid from 0 degrees Celsius to 100 degrees Celsius. Right here, mass, specific heat capacity of liquid times the temperature change of liquid. And then at 100 degrees Celsius, we need the heat for vaporization, the number of moles and heat of vaporization in kilojoule per mole. Finally, we need to heat up the steam from 100 degrees Celsius to 116. The temperature change is 16, the mass is 15 grams, and we have specific heat capacity for the steam. So this is a multi-step calculation. We get 46.2 in the end. Just one more thing. I think this part is larger, or even much larger than any of the other 4 items. So this part is pretty big. The vaporization of water requires a lot of heat.